Okay, we're going to take a few minutes to look at the 8 things packet. If you read through it, please. And we're going to talk about 8 commonly tested topics that are on the AP test. So I'm going to give you a minute or two to read through number 1, which talks about continuity. So how to tell if a function is continuous. If they ask this question not only on the multiple choice but the free response, how are you going to prove that a function is continuous at a certain value? There are 3 things that you need to show. So please read through number 1, and then we need to show the 3 things that prove the function is continuous. Okay, so looking at the 3 pieces, we need to compute the left-hand and the right-handed limits, making sure that you're showing your correct notation. You need to show me that the limit as x approaches 2 from the left of f of x. So how would I compute the limit as x approaches 2 from the left? Plug it into where though? The top, where x is less than 2, right? So I plug it into the top and I end up getting 1 for my left-handed limit. So I need to show this notation. The limit as x approaches 2 from the left is 1. Okay? It also needs me to show the right-handed limit. So I'm going to show this notation. The limit as x approaches 2 from the right of f of x. So how would I compute that? Plug it into the bottom because that's where the function is coming from the right of 2. If I plug that in, I get a 1. So what does that mean about my overall limit as x approaches 2? It is 1. Coming from both directions, my limit is 1. Okay? Part B says compute the function value. So what is f of 2? Is there a hole there? Is there a dot there? And if there is a dot, if there is a value, where is that value at? Is it right where they connect? Or is it somewhere above and somewhere below? And then it's not continuous anymore. So how would I figure out when x equals 2, what y is? So how would I figure out what f of 2 is? Plug it in, but plug it in where? Why the top one? Because that's the function where x is equal to 2. So when x equals 2, you're going to plug it into the top one. What happens when you plug it into the top one? Kind of the same thing that happened when you did your limit, right? But they just need to show this notation. You should get 1. So then part C, you need to show them that you understand that because the limit is equal to the actual function, then that means all the pieces connect and it's continuous. So my part C, I have that the limit as x approaches overall 2 from both directions is equal to the actual value, f of 2. Therefore, f is continuous at x equals 2. If any of those parts weren't equal, then you'd have to say that the limit is not equal to the actual function, which means that f is not continuous. Okay? So if you see this on a free response question, you need to show those 3 things in order to get your points. Left-hand limit using correct notation and right-hand limit using correct notation. The function value f of 2, f of 4, whatever they're asking, and then show me that they're either equal or not equal. If they are equal, then it's continuous. If all those parts aren't equal, then it's not continuous. Okay? Questions? Chris?
When we're doing f of 2, doesn't matter which function we plug in.
Yes, we had to plug it into the top one. So think about why we have to plug it into the because that's where it's equal to 2. So I don't care about less than, I don't care about greater than, I just want to know when it equals to what's the value. So I have to plug it into the top one because that's where it's equal to. What else? Okay, so let's look at the second topic. Second topic is about motion, about position, about velocity, about acceleration. If you have not read number 2, can you please read through number 2 and look at example number 2? Okay? It's talking about speed increasing and decreasing. I'll give you a second to do that. Okay. In order for your particle to either be speeding up or slowing down, you have to look at the signs of your velocity and your acceleration. And on example number 2, it gives you the velocity function. And it's asking you to find the acceleration at t equals 4. So if they give you velocity, how then do you find the acceleration? What? Take the derivative, right? This might be a non-calculator, this might be a calculator. On this question, I'm assuming that this is a calculator question because the type of function it is. So I'm going to assume that this is a calculator question. I'm going to plug my velocity into my y1. I'm going to graph my derivative, and it's asking me to find the acceleration at t equals 4. So once I have my derivative graphed in my calculator, how would I figure out the acceleration at t equals 4? Graph it and then do second trace value 4. You need to do second trace value 4 in your derivative, which is going to give you what again? The acceleration at 4. When you do that, when you get an acceleration at 4, you should get negative 0.293. That's acceleration at t equals 4. You'd probably get 1 point for that. The second part of the question, though, says, is the speed of the particle increasing or decreasing at t equals 4? So we found the acceleration was negative. Does that mean he's decreasing? Not necessarily until I pay attention to what's happening with his velocity, right? So then how would I figure out his velocity at t equals 4? I need to plug in a 4 into my velocity function. So making sure in your calculator that you turn off your derivative, that you turn on the velocity function, then you can do second trace value 4, and you should end up getting 0.172, positive 0.172. They will need to see both of those values. Okay? So do you have the velocity at 4? Do you have the correct acceleration at 4? Okay? All right, so my velocity is positive, my acceleration is negative. What does that mean about the speed of my particle? He's decreasing. Justify your answer. A very simple, easy, basic, good enough explanation so you're not saying too much. The speed is decreasing because the velocity and the acceleration have different signs at t equals 4. Okay? If you've listened to the tip show, I tell you and explain to you that please don't say too much, because if you go on and you say too much and what you've said is now incorrect, you lose your point. So please be careful. Just say what you have to say and be done. Okay?
Should we use abbreviation or
It depends on the abbreviation that you're using. Can you use DEC for decreasing? Yes. But I would be careful using other abbreviations that they don't know, because they don't know who you are from anybody, so they don't know how we worded it in class and stuff like that, so I'd be careful.
When you're saying at, could you just use the at sign?
Yes, you can use the at sign.
What about like with or like because?
I think that would be okay, but things like DIF, does that mean differential? Does that mean difference? Does that mean, what does that mean? Okay, so just be careful. Another thing, like using positive and negative signs, just be really careful with how legible you are. Some of your handwriting is a little bit hard to read, and I've been able to interpret it because I know you and I'm used to you, but some stranger is going to be reading your AP test, and they don't know who you are, so they're not going to know that you do your 8s this weird thing and that's supposed to be an 8. Okay, so make sure that they can read what you're writing. Okay? All right. Part B, how far did the particle travel over a given interval of time and with what average velocity? So this is another commonly tested topic. Will you take a second to read Part B and look at example number 3? Okay, example number 3 gives us a velocity function, and it says how far did the particle travel over the interval from t equals 0 to t equals 2. So I want to figure out how much he's traveled. Has he gone positive and negative and positive and negative, and what's the total distance? So when I do total distance, I have to do what? Absolute value of velocity. I need to integrate the absolute value of velocity from 0 to 2. So then what if they gave me position, the position function, and they asked me to find the total distance?
you would have to
Wouldn't I have to find the derivative of position first, which is going to give me my velocity? Then I can integrate the absolute value of him. But you should not be integrating your position. You should not be integrating your position function. You should be integrating who again? The absolute value of velocity. So if they give you position, you've got to then find the velocity function first before you can then integrate him. Okay? All right, so you're integrating the absolute value of velocity because they're asking you to find the distance that he's traveled, not just his position at 2. They're asking his total distance that he's traveled. Absolute value of velocity on that one from 0 to 2 would be 1.582. Okay? So then part B says, what is the particle's average velocity? How do you find the average of anything? Add them all up, then divide by however many there are, right? Since they gave you the velocity function, you're going to add them all up, aka integrate them, positives and negatives. So I don't want absolute value on this one. I want to add them all up and divide by however many there are. So I want to divide by 2, from 0 to 2 is 2 units, right? So I end up getting negative 0.582. So the average would be negative. You're decreasing more than you are increasing. Okay?
Can you do the f of 2 minus f of 0 over 2 minus 0?
So you're doing you mean v of 2?
Yeah.
Okay, so if you do v of 2 minus v of 0, so you're finding the slope. Is that what you're really doing? You're doing a y2 minus y1 over x2 minus x1. If you're doing the slope of the velocity, what is that? That's acceleration. And are you finding acceleration, or are you wanting to find average velocity? And you already have the velocity.
But if you give you like position, would you do that then to find average?
Yes. So then if they give you the position and you wanted to find the average velocity, then you can find the slope of the position at it's mean value theorem. At some point the average position will be the same as the slope.
Okay.
Okay? Okay, so be careful with that. What does part C say? What is the position of the particle at a specific time, given an initial position and a velocity? So if I ask you, what is this particle's position? What does part C say? So here's example number 4. Over the interval from 0 to 3, a particle moves along the x-axis with a velocity of blah, 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 blah. Given that his position at t equals 0 is 4, so his initial condition, he starts off at positive 4. What is his position at t equals 3? But all they give me is the velocity. So how would I figure out his position at t equals 3? You're going to integrate who? Velocity. I can do positives and negatives, because maybe he moved right, then he moved left, then he moved right, then he moved left. I want to figure out where he is at t equals 3. So I integrated his velocity from 0 to 3. But what do I have to consider? His initial position. What if he started way down at negative 100? He moved back and forth and back and forth and back and forth. Wouldn't that be different if he started at 0 and moved back and forth and back and forth and back and forth? Or if he started at positive 4 and moved back and forth and back and forth and back and forth? So you have to always, always, always consider his initial position. Unless they just asked, how much did he move in the 3 seconds, in the first 3 seconds? Then you can just integrate from 0 to 3. But if they're asking me what his position is after 3 seconds, or after 3 minutes, or whatever this is, you have to consider where he started, then add his change from 0 to 3. Okay? I would say that this one is probably a calculator one, because we don't know how to integrate that. Even with U substitutions, it wouldn't quite work. So I would say that this was a calculator question. I got 4.774.
Would you lose points if you were to just write the integral and then add the 4 afterwards and not have it in the original setup?
That's a hard question. I don't know, to be honest with you. I don't know if they care when you add it, as long as you make sure that you show your work and where you added it from. Yeah. I would also be careful, too, that you don't squeeze your 4 behind here and accidentally integrate including your 4. Make sure you're just integrating your sine of t squared, and then you're adding your 4 before or way after you integrate. Does that make sense? So sometimes people put a plus 4 at the very back and then forget that it's an initial position, and then they integrate it with that 4 in there. Okay? Good? Okay. So number 3 is net change as the integral of a rate. So let's read through. I'll give you a few minutes to read through number 3 and see what's going on with number 3. Okay. After you read number 3, this is talking about rates of change and stuff like that. This is another obviously very important topic, commonly tested topic. the two major things here is making sure that you can interpret what derivatives mean. You could interpret what integrals mean. You could interpret what it means to integrate the derivative or integrate a rate. You can interpret what all those things mean. The other important thing is units. They're going to start throwing in units on these types of questions, and they're going to put specifically in there considering the units or something about the units. So you need to make sure that you represent the units correctly in your answers, because that's how they're going to give you some of your points, is using the units correctly. Okay? It says on example number 5 that f is the function that represents the rate at which water is flowing out of an outlet. So if this is a rate, what does f really represent? The derivative, right? So f is the rate at which water is flowing out of an outlet pipe, measured in thousands of gallons per minute. If I were you on the test, I would do things like that, circling or underlining key important words so that I remember to include those. It says for part A, how much water flowed out of the pipe during the entire 10-minute interval. So how would I figure out if this is the rate at which water is flowing out? How would I figure out how much water is flowing out? Integrate it. Integrate f from 0 to 10. Okay? I'm assuming that this one is also a calculator question. When you integrate f from 0 to 10, you should get 12.970. What? What does that represent? 12.970 is what? Thousands of gallons that have been poured out of this pipe or whatever. Okay? Thousands of gallons. For part B, using correct units, so that's how they'll make sure that they're giving you points for using the correct units, explain the meaning of the integral of f from 0 to 5. So what does it mean to integrate f from 0 to 5? What's that answer going to represent? Luke?
The integral represents thousands of gallons in the pipe over a 5-minute period.
I like that. So the, say it again, the integral represents the amount in thousands of gallons.
It represents thousands of gallons of water leaving the pipe over a 5-minute period.
Perfect. I like that you said the time limit also. And then you use units, so it's thousands of gallons that left the pipe in the first 5-minute or the 5-minute period. Okay, or you can say from t equals 0 to t equals 5. But they are looking for units, thousands of gallons. They're looking for flowing out of the pipe, and they're probably looking for a t equals. So that t equals 5, or in the first 5 minutes, or from t equals 0 to t equals 5. Okay?
And that's what I think of per minute.
It is not per minute. It's the amount of water. It's not the rate at which the amount of water. So I would not say thousands of gallons per minute, right? So that's the important part. If you're taking the rate, the per minute, and you're integrating it, aren't you going to the original function, which is just the amount? So it's just the thousands of gallons. Okay? So don't say per minute, because that would be incorrect. All right, part C. Using the correct units, explain the meaning of the integral of f from 0 to 5, but this time, if I multiply it by 1/5, so what does that do? You're adding up and dividing by the amount. Average. It's the average what, though? It's the average rate at which water in units, thousands of gallons per minute. It's a rate this time. Okay? If you integrate and you find the amount, but then you go back and you divide it by 5 minutes, isn't that amount per minute? So you're back to a rate. You just integrated and gotten an amount. Then you went back and divided it by time, so it's rate per, it's amount per time. So you're actually doing a rate. It's the average rate at which water in thousands of gallons per minute was flowing out of the pipe in the first 5 seconds, or from t equals 0 to t equals 5. It is not just the amount. It is not the average amount. It is the average rate at which water is flowing out in thousands of gallons per minute. Did you hear that? It is not the average amount. It is the average rate. Okay? Think about your units when you do that. This makes it a little bit easier. Okay? Questions on that one? That's a very commonly asked topic to interpret. Okay. All right, let's look at number 4. This is about Riemann sums and trapezoid rules, and if they give you, they maybe will give you a graph, but they maybe will give you a table of values, and they're going to ask you to estimate using Riemann sums or trapezoidal rule. But, and we've said this all along, that the heights of your rectangles or the heights of your trapezoids aren't always going to be the same. A lot of times they're actually not going to be the same to make sure that you're paying attention. So you can't just figure out that there's 12 units, divide it by 3, and then you assume that they're going to be a 4 all the time. You have to make sure that you're paying attention to what your base times height is, what your base times height is, what your base times height is for each rectangle. Or what is your base 1 plus base 2 times the height divided by 2. Base 1 plus base 2 times the height divided by 2. They all might be different, so you have to take that into consideration. Okay? Read through this one if you have not, and let's do the next example. Okay, looking at this problem, you have to be really careful with the wording, and they try to a lot of times sneak some words in there that if you're reading it too quick or not remembering all the words that they use, those might be important words later on. The important word that I see here as soon as I start reading this is non-decreasing velocity. Why wouldn't they just say velocity? Because they want you to know that it's a increasing velocity. Her velocity is always going up. It is never going to drop down, go negative. It is always going to be an increasing velocity. So if you were to graph this function, the function would be increasing. That is a super important word that they slipped in there. If you didn't recognize it, it's going to be important later. She has an increasing velocity in meters per second during the time intervals from 0 to 12 as shown in the table below. So the information that they give you is in meters per second. So that's her velocity, right? Okay. And then it says here, use the data in the table to estimate Carmen's acceleration. So how do I go from velocity to acceleration? Derive, but they don't give me a function to derive, right? So that makes it a little bit tricky that they don't just give me a velocity function that I can derive and then plug in a 7, right? So how am I supposed to find an acceleration if they don't give me an actual velocity function?
That's why I went over.
Okay? So the slope of my velocity, what's the slope of my velocity, or the rate of change in my velocity the same as? The derivative or the acceleration, isn't it? The rate in which my velocity is changing, the derivative of my velocity, isn't that the same as acceleration? So can I use the 2 points that are closest to t equals 7 and find the slope of my velocity? The slope of my velocity is going to give me the same thing, or an estimate anyway, of my acceleration. Okay? So that's what I did here. I took my 5, 7, and my 9, 10, and I found the slope of my velocity, which is the same thing as the acceleration. It's an estimate because we're using 2 points on either side, but at some point, the slope is the same as your instantaneous. That's the mean value theorem. You should get 3/4, and what is your units? What do those 10 and the 7 represent? Meters per second, and then what does the 9 and the 5 represent? Another second, so your unit should be meters per second squared. Okay? Kind of tricky. Part B. Use a trapezoidal estimate for the 4 sub-intervals to estimate how far Carmen traveled during the 12-second interval. Did it say that those sub-intervals, those 4 sub-intervals had to be equal? No. They just want you to use 4 trapezoids. So you can assume that these 4 trapezoids are going to have equal heights or bases or whatever. So I suggest always, always, always draw a picture. Why not? Okay? My first time is 0. My next time is 3. My next time is 5. My next time is 9. My next time is 12. And then I even put my y values at each of those times. So if I'm looking at these 4 trapezoids, What is the height of my first trapezoid? From 0 to 3 is how much? 3. What is it from 3 to 5? 2, not 3. What is the height from 5 to 9? 4, not 3, not 2. What is the height from 9 to 12? The heights are all different. You have to do 4 separate trapezoid areas and then add them together. You cannot take out a b minus a over n because they don't all have the same heights. Okay? So you're going to have to do 4 separate trapezoid areas, base 1 plus base 2 times the height divided by 2, and then add them all together. They will probably do this on the test to make sure that you're paying attention. Okay? Okay.
Oh, because the height goes out this way.
Your base 1, your base 2 are your y values, times the height is the distance between your 2 parallel sides, is the x.
So it's y.
Y plus y times x is divided by 2. You get 95 meters. Because what you're really doing is you're figuring out how far she's traveled. So just meters. Okay. Part C, use a left Riemann sum with 4 sub-intervals. So I don't, again, necessarily know, do I know that they're equal? No? I don't necessarily know that they're equal again, right? It's the same information, so I don't think that they're equal. It just says 4 sub-intervals to estimate. Ooh, what does that mean? The average. Average rate. The average rate, first 12 seconds. Using correct units, so I need units on there. Describe the meaning of the quantity in the context of the problem. So you're going to use Riemann sums, that means rectangles. So again, go back to your picture. Go back to your picture of your increasing function. Use left endpoints, that's going to be key too. So using left endpoints, what is the base of my first rectangle? 3. What is the height of my first rectangle? 4, because I'm using the left endpoint. What is the base of my next rectangle? 2. What is the height of it? 6, because I'm using the left endpoint. So keep going. Base 1 plus base 2, base 1 plus base 2, base 1 plus base 2. That is finding the area underneath the curve. What's another word for finding the area underneath the curve? Integrals. Isn't that what they're asking you to do? Find the integral from 0 to 12. I don't really know what it is because I don't have a function, but I can estimate it using Riemann sums. Don't forget to divide by the 12 in the front because that's what they're asking you for, the average. We just added them all up. That was her distance. Then we divided by 12. So isn't this distance per time? This is a rate, 6.833 meters per second. So this is the average rate, or the average velocity is 6.833 meters per second in the first 12 seconds. Make sure you refer to the time also. Okay? It is the average rate, the average velocity in meters per second in the first 12 seconds. Okay?
So I went on the path of underestimate and overestimate. Would that be saying too much? Like,
That would be saying too much.
okay.
If they didn't ask that, okay? If they did ask that, that's another commonly asked question. If they ask that, is it an underestimate or an overestimate? What would you say? Why? Because your function is increasing, and if you were using left Riemann sums, wouldn't your rectangles be below your function? So then it would be an underestimate, okay? So that's why it's important to make sure that you read the question. It did not ask you for that, so I wouldn't necessarily spend the time to talk about that. You're going to run out of time. I mean, you're going to be there for 3 hours and 15 minutes and wish you had more time.
Okay. So how do I know that it was talking about that rather than overestimate?
They would ask you in your question, is it an overestimate or underestimate?
Okay. So they'll be explicit about that.
Correct. Okay. All right. Because we are running a little bit out of time, what I'd like you to do for your homework over the weekend is do 5 through 8. Okay? We still have 5, 6, 7, and 8 topics, right? I'd like you to read through those, and I would like you to do 5 through 8. I'll be checking that the next time I see you, and then we'll start going over those and then start practice testing. Okay? Make sure that you're paying attention to the calendar of when I am here to make your corrections on your practice test so you can make arrangements for that. You will need to be here for at least an hour and a half to do test corrections, making sure you're correcting your mistakes so you don't make those again. Okay?